All right, this video we're going to take a look at sampling. We're going to look at frequency distributions, frequency polygon, stuff like that. This right here, it doesn't get into a lot of detail like a normal statistics class would. So it's just kind of, kind of brushes over it a little bit. We'll look at histograms and stuff like that. So the first thing I want to discuss before I get into the problems here. Now, what I'm fixing to write down has nothing to do with working the first example. So the first thing I want you to know is population and sample. Okay. So you can collect data and stuff, and you can have a population or you can have a sample. So a population is the set containing all the people or objects whose properties are to be described and analyzed by whoever's collecting the data. And a sample is a subset of those people. In other words, let's say at your university or high school or whatever. So let's just say at a school, you want to know the heights of the students. You want to know how tall they are. So one thing you could do is you could ask every single student at that school how tall they are. And that would be a population. But that might be kind of hard to get that data to ask every single student. So the other option you could do is say, like, all the classes you're taking. You could ask the students just in your class. That would be a sample. Okay, so that's the difference between a population and a sample. All right, so now let's get into this and let's look at a couple examples. So it says a group of hotel owners in a large city decide to conduct a survey among citizens of the city to discover their opinions about casino gambling. So the first thing they want us to do is to describe the population. So here, the population is what? Is the set containing all citizens of the city. That would be our population. All right. And then part B, it says one of the hotel owners suggests obtaining a sample by surveying all the people at 6 of the largest nightclubs in the city on a Saturday night. Each person will be asked to express his or her opinion on casino gambling. Does this seem like a good idea? All right, so you've got an entire city, and of course you're probably not going to be able to go ask every single person in the city. So they said, well, we'll pick just a sample from that. We'll pick some people and ask them. So they're going to go to nightclubs, 6 of them, and ask those people what they think about casino gambling. So is that a good idea? That's what we're looking for. That's one of the important things about statistics is when you're collecting your data, you got to make sure you collect it in a way that's not biased, okay? Where you're not going to skew your results or anything. So in this case, questioning people at 6 of the largest nightclubs, that's probably not a good idea, right? Okay. The nightclub is a subset of the city, but more than likely, wouldn't you think that they would agree with casino gambling? So that might kind of skew the results. So we might need to think about a different way to choose our sample. Okay, so that's what they're trying to get you to understand with this example 1 here. All right, so now let's look at a random sample. A random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected for the sample. Okay, so you're just randomly picking people, but everybody has the same chance of being selected. All right, so let's take a look at example 2, and it kind of goes through and clears that up. All right, kind of you get more of an idea of what a random sample is. So let's go back to the hotel owners who are interested in how the city's citizens feel about casino gambling. Which of the following would be the most appropriate way to select a random sample? All right. So what about randomly surveying people who live in the oceanfront condominiums in the city? Okay. So that might not be a good idea, okay? Because maybe there's a lot of hotels that are on that ocean front, okay? And the property owners, they might not want all that traffic and noise in the casino and the gambling and all that stuff, okay? And plus, that doesn't give every citizen an equal chance of being selected because you're going just to that ocean front, okay? Well, let's look at option B. Survey the first 200 people whose names appear in the city's telephone directory. Well, that's probably not a good idea either, is it? Because, if you're looking at the first 200 names, then how about the people whose name ends in W or S or something like that? They have no chance of being selected. Okay, if their last name begins with a letter towards the end of the alphabet, there's no chance of them being selected. And so let's look at option C. Randomly select neighborhoods of the city and then randomly survey people within the selected neighborhoods. Now, see, that's a good idea there, because so you've got all the neighborhoods in that city. You're looking at all the neighborhoods in the city, and you're going to randomly select. Maybe you can number the neighborhoods 1 through however many neighborhoods there are. Say there's 100 neighborhoods. So you could put numbers on each neighborhood 1 through 100. And then maybe you can get a random number generator and generate, say, I don't know, maybe 20 numbers. And whatever 20 numbers come up, those are the neighborhoods you select. And so now you've got those neighborhoods selected, and then you're going to go in each neighborhood and randomly select people. Okay? So that's one way. Or what you could do, you could say, okay, I'm going to randomly choose 10 neighborhoods. And instead of going in there and randomly selecting people out of each neighborhood, you could just randomly select 10 neighborhoods and say, okay, we're going to serve all those people in those 10 neighborhoods. All right. So that's what they're talking about, when they're talking about random sampling and stuff like that. All right. So the next thing that we need to look at is we're going to look at frequency distributions. Okay. So frequency distribution, that's a good way to organize your data where you can see it a little better. Okay. So a piece of data is called a data item. Okay. And collected data, if you collect data, you can present it using a frequency distribution. Okay. And that's what we're going to do with this problem here. Okay. So you can see here it says construct a frequency distribution for the data of the age of maximum yearly growth for 35 boys. All right, so I guess I'm assuming what this author means with this problem is, okay, at this age, this was the maximum that they grew in that year. Okay, in year 12, that kid grew the most it would grow in any other year. Okay, and so these are their ages. Okay, that they grew the most. So this kid, he grew the most when he was 12. This one grew the most when he was 14, and so on. So, you know, we can look at that. What does it tell us? What does it tell us? Well, it looks like a bunch of numbers, doesn't it? So what we want to do is we want to put it in a frequency distribution. So what we're going to do here is we're going to create a table. So here we're going to have, we'll do it in this color. So we'll have a column for age of maximum growth. Okay. And so we've got to be able to take in all the ages. So you'll need to go through the list and you'll need to find the youngest and the oldest. So it looks like the youngest is 10 and the oldest is 18. So I need 10, 11, 12, 13, 14, 15, 16, 17, and 18. And if you want to, you could put some lines in here to divide them up so you can, you know, make it out better or something. So there we go. All right. Now we need another column called, now I'll write it on out, called frequency. And what the frequency is that is how many boys were age 10. So you have to go through here and count all the 10s. And there's this 110 here. And so that frequency would be 1. And then we would have to go through and count all of the 11s. So you would come through here, there's 11, there's 1, 2, and that's all of them. There's 2. And then you would go through and count the 12s. So there's 1, 2, 3, 4, 5. So there's 5 boys that were 12. And so on. And you would continue on with that. And I'm not going to go through and do all of them, but that's 7, 9, 6, 3, 1, and 1. And that's your frequency distribution table. And so now what that does is it organizes the data so we can make a little more of it. Okay? So it looks like the age that boys grow the most, it looks like it's 9. You see that? So you can easily see that, answer questions, and you can see the age that not many boys grew the most was age 10 and 18 and 17. Okay? So that's something you can do there to to just organize the data and look at it. All right. Now, let's see, what's the next example? Okay, so there's another frequency distribution that we're going to do, but we're going to use classes and stuff like that. All right, so I hope that makes sense. We'll come back to this problem in a minute for something else. All right, so now let's look at this, and I actually want to take this and just kind of move it. Let's move it over here so I can work right here. All right, so it says use the classes 40 to 49, 50 to 59, all the way 90 to 99 to construct a grouped frequency distribution for the 40 test scores below. All right, so the group distribution, it's a little bit different than what we just did. We're going to group them into classes, into intervals. So you can see they give us the intervals here. Now, I don't know why, but in this class, it's not asking you to to figure out the class width and all that stuff. Like, how do we know it's 40 to 49, 50 to 59? Well, that's given to us in the problem. Okay. In a statistics course, a regular statistics course, they would actually ask you to calculate this. There's a way to do it. And if you want to look into that, just search my channel for creating a frequency distribution, and I go over how to do all that, how to find that. But in this one, they give us the classes. And so if we come over here, we set up our table. So we've got test scores. And we've got 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. And then we're going to do our frequency. All right. So what we have to do is we have to go through this list and count how many values are between 40 and 49. And 40 and 49 would be included in this interval. Okay? So let's go through there and count that one. So between 40 and 49, so I've got 1, let's see, 2, 3. So there's 3 of them. Okay. And then I would go through and count all the ones between 50 and 59. I'll go ahead and do that one too. And then then you can pause the video and do the rest if you want to. Between 50 and 59, so there's 1, 2, 3, 4, 5, 6. So there's 6 of them. All right. And look, and we can come over here and put our lines so we can do that. All right. And then we would go and count all the ones between 60 and 69 and so on. And that ends up being 6, 11, 9, and 5. All right. Now, there's some terminology to give you. This 40 over here, this 40, that is called the lower class limit, and the 49 is called the upper class limit. Okay, so from that table, that's the 40 and the 49, and then also the 50 would, the 50, 60, 70, 80, and 90, those would be the lower class limit, and the 49, 59, 69, 79, 89, and 99, those would be called the upper class limits. Okay, this is just the lower limit of the first class, this is the lower limit of the second class, and so on. And then we get into, and I think I mentioned this earlier, the class width here is equal to 10. We didn't go over how to find it, but basically what you do is the class width, you would actually calculate this number, and that helps you set up your classes here. So you start out, you pick what you want to start out with. So in this case, 40 was a good number to start out with. And so what you do is you add 10, you add the class width to the lower limit, and that gives you the lower limit of the next class. And then you add 10 to that, that gives you the lower limit of the next class, and so on, all the way down. and then you can fill out your upper class. Well, if that lower limit's 50, then that's going to go from 40 to 49, and so on. Okay? And that's creating a grouped frequency table. All right? Now, here, let's see, what do we got? All right, so that's stem and leaf. But before we go on to that, before we go on to the to that stuff, let's just talk briefly about a histogram and a frequency polygon. Okay, so let's look at a histogram based on this table here, on this one. So if I draw a histogram, I've got something that's going to look like this. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. I've just, how did I know to go to 9? Because that's the largest value. That's what I need to go to. And then over here, this axis, this horizontal axis here, that's going to be 10, 11, 12, 13, 14, 15, 16, 17, 18. So 10, 11, 12, 13, 14, 15, 16, 17, and 18. And what a histogram is, now remember on a histogram, the bars that you draw up, they have to touch. Okay, they've got to touch. So you can see here on the 10, this bar would go to a height of 1. Because see, the frequency is 1. And then for 11, that would go up to 2. So that goes up to 2. The 12 would go up to 5. The 13 would go up to 7. The 14 would go up to 9. The 15 is at 6, so that's about right in there. 16 is 3, so that's back down here. 17 is 1, and 18 is 1. And so that's what the histogram would look like. Okay, that's what your histogram would look like. And I guess I could draw these a little bit better. All right. So that's a histogram. That's your histogram, and you would label it. This is that's the ages there. And then this would be your frequency. That's the number of boys. And then the other thing that we can draw based on this histogram here is a frequency polygon. So the frequency polygon, that's just connecting the midpoints of these bars here. So I've got the midpoints here. And the midpoints are just 10, 11, 12, and so on. And I would create a line like this. And that line in red there, that's your frequency polygon. But now it's not finished because it has to come back down and touch this horizontal axis here. So the next midpoint would be what? 19. And the next midpoint here would be 9. And so for a frequency polygon, it goes to the horizontal axis where the next midpoint would be. And you could draw the frequency polygon on top of the histogram, or you could move it off and, you know, you could erase the histogram or whatever and just leave the frequency polygon. All right. So I hope that made sense. Like I said, this class doesn't get into a lot of depth with this stuff. But if you take a regular statistics class, it will. Okay. Oh, it looks like this is the last problem, huh? So constructing a stem and leaf plot. All right. So to construct a stem and leaf plot, that's another way to look at data. I'm gonna move that maybe right there. Well, maybe move it back. All right. So to create a stem and leaf plot, we need the stem. Let me draw it down here. The stem and the leaf. All right. And so we can see that the smallest number we have is in the 40s. The largest number we have is in the 90s. So I need 4, 5, 6, 7, 8, and 9. Okay. All right, so it says use the data showing statistics test scores for 40 students to construct a stem and leaf plot. All right. So all we're going to do is just write them down. So if we look at this, let's see, we've got 82. So I would put the 2 there. 47, 75, 64, 57, 82, 63, and 93. So you see what I'm doing? I'm just going through here. 82, 82. Okay, the first digit is the stem and the last one is the leaf. All right. Now, yeah, sometimes you may have something like 123, 135, something like that, 3-digit numbers. Well, on that, you would have the stem, you would have 12 and 13, and then this would be 3, 5, and this would mean 123, 135. Okay? It's the last digit's going to go over here on the leaf. All right, so I left off at 93. So now I need 76, 68, 84, 54, 88, 77, 79, 80, 94, 92, 94, 80, 94, 66, 81, 67, 75, 73, 66, 87, 76, 45, 43, 56, 57, 74, 50, 78, 71, 84, 59, and 76. Okay, you get the idea of what to do. And hopefully I didn't miss something. I hope I didn't. But if I did, then I just missed, I just missed a number or something. But the main thing is you getting the idea of what to do. All right. And then we've got stem, leaf. All right. And so what you have to do then is you've got to go back through and put them in order. Okay. And I'm not going to go through and put all these in order, but we'll do a couple of them. So this would be 4, 5, 6, 7, 8, 9. And so that would be 3, 5, 7. This would be 0, 4, 6, 7, 7, 9, and so on. Okay, you would go back and put them each in order, and then you have all the data values. But look, one thing that you can get from a stem and leaf plot is if you look at this thing, if you look at it sideways, it kind of looks like the bars of a histogram, doesn't it? You see that? So that kind of gives you a good idea of what the data represents. Okay, and then the other thing that you want to do once you finalize this and you get all this stuff in order and everything, you need to come up here and I just go through here and pick one of them. So I would just do 4 or 5 and draw it up here. Is grade means 45 on 45, I guess, for test grade. And what that does is that's just, okay, I'm coming down here, I'm just gonna select a random one. I mean, you could do 5-4 if you wanted to, or 5-6. But we're just letting the person who's looking at this stem and leaf plot, we're letting them know that this means the student made a 43 on the test. This one made a 45, this one made a 47 on the test. It's kind of like a key, okay? So they know what's going on. Okay? And yeah, that's not a very long section there. And like I said, in this class, this does not get into real detail about all this stuff. So hopefully the video helped. Check out my other videos. Give me a like, share, and subscribe. And thanks for watching.